Ninth chapter, Ray Optics and Optical Instruments. Let us start with laws of reflection. Then different types of spherical mirrors. To study any topic properly, we have to know important terms used. So here also, let us go through important terms like aperture, pole, radius of curvature, center of curvature, and so on. Then formation of image by spherical mirrors. So to know the formation of image, we should know focal length, focal plane, then virtual object, virtual image, real object, real images. So let us understand all these things in this session, and after that, formation of image by concave mirror. Students, you have to copy notes. Okay. To draw diagrams, use scale, pencil, eraser and draw neatly. Okay. If you don't get the diagram in first shot, then redraw the diagram. Again, if you don't get it, redraw one more time. Doesn't matter, but it is worth spending. Make sure that diagrams are neat and all specifications are in the diagram, mentioned in the diagram. Specifications mentioned in the diagram means the principal axis, shades in the diagram, focal length, center of curvature, and all those lengths should be mentioned properly. Few important points with respect to ray optics. Most of the points you are already aware of these things. Let us rush through all these points once. Light is a form of energy, like sound, heat, vibration. Light is also a form of energy. Next, visible range of light is about 400 nanometer to 800 nanometer. 400 nanometer to 800 nanometer. It is about 400 nanometer to 800 nanometer. There is no clear-cut wavelength to say that it starts from this wavelength to this wavelength. So that is why it is appropriate to mention it is about. This 400 nanometer can be written as 4000 into 10 to the power of minus 10 to 8000 10 to the power of minus 10. This 10 to the power of minus 10 meter is nothing but angstrom. So it is about 4000 angstrom to 8000 angstrom. Next, speed of light in vacuum is same for all wavelengths and is approximately equal to 3×10⁸ meter per second. This is a beautiful number, magic number, and this is always approximate number because this value depends on the experiment. So after doing experiment, after measuring the speed of light, one should get this, right? Many experiments revealed that it is very close to 3×10⁸ meter per second, not exactly 3, but still widely accepted value for all our calculations is 3×10⁸. Next, optics. Optics is a branch of physics which deals with the study of light and optical devices. Light and optical devices. Optical devices means it could be spectacles, lens, mirrors, binoculars, telescopes, microscopes. All those comes under optics. Next, rectilinear propagation of light. It says, in a homogeneous medium, light travels in straight line. As long as the medium remains same, homogeneous, light always travels in straight line. That is rectilinear propagation. Next, ray of light. A ray of light, a straight line along which light travels, is called a ray. So if this represents a ray, then this is the direction in which light is traveling. Next, beam of light. Beam of light is bundle of rays. If this is white light, you know white is mixture of many wavelengths. So it is appropriate to use the term beam, beam of light. If this beam of monochromatic wavelength has number of rays, then call this as beam. Next, ray optics. It's a branch of physics which deals with the study of phenomenon of light by considering geometry. For that reason, ray optics is also called geometrical optics. Laws of reflection. First law, the incident ray, the reflected ray and the normal drawn at the point of incidence lie on a plane. If this is a reflecting surface, this is the incident ray. This is the normal drawn at the point of incidence. Then this is the reflected ray. This is called incident ray, normal drawn at the point of incidence, reflected ray. These three will lie on a plane. That plane is this white paper. The first law says if this is the incident ray, normal, this ray cannot come out of the plane of the paper like this. If it is coming out of the plane of the paper, then that reflected ray cannot be confined to the same plane. Second law, the angle of incidence is equal to the angle of reflection. I equal to R. So in ray optics or geometrical optics, I represents angle of incidence, R represents angle of refraction. If you write like this, then also it is fine. If you forget the arrowhead, then also it represents angle. Okay, don't get confused. I, R, this also represents angles. Spherical mirrors. So here we deal with two types of spherical mirrors. One is concave, the other one is convex. In the case of concave mirror, convex surface is coated with suitable material. Thereby, the concave surface becomes reflecting. So reflecting surface is shown by this smooth side and coated surface is represented by this shading. So this is concave mirror. Convex mirror means convex surface. The bulged surface should be the reflecting surface. That is why the concave face must be coated. So this is how concave and convex mirrors are represented. Now, important terms in spherical mirrors. First is center of curvature. Center of curvature. Center of curvature is represented by capital C. It is the center of the spherical surface in which mirror forms a part. Suppose this is a concave mirror, and this concave mirror is part of this imaginary sphere. Students, try to follow. Imagine a sphere. This part, this surface is part of this imaginary sphere. Therefore, center of this imaginary sphere is called center of curvature of this mirror. Since it is coated outside, bulged surface is coated, it should be a concave mirror, isn't it? And this is called center of curvature. Then, small region available for reflection is called aperture. So this small region in this mirror is called aperture. Center of this aperture is called pole, denoted by capital P. So center of aperture is called pole. An imaginary line passing through center of curvature and the pole. This imaginary line is called principal axis. This imaginary line is called principal axis. Principal means main, major. Principal axis. And the distance CP, which is radius of this sphere, is called radius of curvature, denoted by R, capital R. Let me repeat. This mirror is part of this sphere. So that is why this is called a spherical mirror. So in this case, outer surface is shaded. Let me shade this again. So outer surface is shaded means bulged surface is shaded. Thereby this represents a concave mirror. Center of this imaginary sphere is called center of curvature. Small region available for reflection is called aperture. And center of that aperture is called pole, denoted by P. An imaginary line passing through center of curvature and pole is called principal axis. Principal. It is not PLE. Principal means major axis. CP. This distance is called radius of curvature, denoted by capital R. Go through the terms once. Students, please copy all this. In ray optics or geometrical optics, many parameters are involved. Many parameters means focal length, radius of curvature, object distance, image distance, height of the object, height of the image, like this. Okay. So it is appropriate to consider the direction of light. So with respect to direction of light, with respect to reflection, incident direction, one has to fix the formula. So that is why we consider sign convention. So simplest sign convention is Cartesian sign convention. In analytical geometry or coordinate geometry, you have heard of this Cartesian plane, isn't it? So in Cartesian plane, in Cartesian sign convention, this is y-axis, x-axis, origin, this is positive x-axis, negative x-axis, positive y-axis, negative y-axis. So distances to the right of the origin are taken with positive. To the left are taken with negative. Distances above the origin is taken with positive. Distances below is taken with negative. Similarly, in ray optics with respect to spherical surfaces or spherical mirrors, Cartesian sign convention is used. If this is a spherical surface, spherical mirror, principal axis, pole, just to represent a mirror, concave mirror, okay. Compare this with this. Distances to the right are taken with positive. Distances to the right are taken with positive. Distances to the left are taken with negative. Here origin is the reference, here pole is the reference. Heights or distances above pole are taken with positive. Below the pole are taken with negative. Okay. So just like Cartesian sign convention, here also we use. So that is why Cartesian sign convention in refraction through spherical mirrors. Now, first sign convention says all distances are measured from the pole along the principal axis. If this is a mirror, principal axis, this is some object, here is a tree, okay. This is the mirror. This tree is the object for the mirror. If tree is at a distance 10 meter from the mirror, then the 10 meter is from foot of the tree to the pole. So this is taken as object distance. This is pole. You can say, sir, this is the object, this is the mirror, therefore distance between these two can also be the object distance, isn't it? The answer is no. The sign convention says the distance should be measured from the pole along the principal axis, along this line only. You should not go leaving that principal axis. So you cannot take this as a measure of object distance. Similarly, you cannot take this distance as a measure of object distance. So all distances are measured from the pole along the principal axis. Second point, the distances measured to the right of the pole, distances measured to the right are taken with positive, to the left are taken with negative. And distances above the pole are taken with positive, distances or heights below this are taken with negative sign. Students, this is important for 1 or 2 marks. Note down and go through once. Now let us go through reflection through spherical mirror, both convex and concave. Thereby let us understand focus, focal length, real image, virtual image, and how to trace the reflected rays. Students, use scale pencil to draw these diagrams. Don't just scribble, write it neatly, okay. This is for your reference, and the way you draw diagrams shows your interest. Make sure that you draw neatly. This is for principal axis. This is a concave mirror. Since it is concave mirror, convex surface should be shaded like this. This is incident ray along the normal. This is incident ray along the principal axis. If there is an incident ray along the principal axis, after reflection, it retraces the path like this. So this is something similar to a plane mirror. This is the incident ray. For normal incidence, incident ray falls on the mirror and travels back in the same direction, isn't it? Because here angle of incidence is 0 and angle of reflection is also 0. So this satisfies that I equal to R. If this is plane mirror, normal run at the point of incidence, this is the incident ray, then this should be the reflected ray. Thereby this angle equal to this angle. Angle of incidence equal to angle of reflection. But if the incident ray is along the normal, then angle of incidence becomes 0. Therefore angle of reflection is also equal to 0. So that is this ray. Now let me consider few more rays close to the principal axis and parallel to this principal axis. So these rays will undergo reflection and they pass through a point on the principal axis. So this point on the principal axis is the focus, denoted by capital F, and the distance of the focus from the pole, this point is the pole. Distance of the focus from the pole is called focal length. So this is focal length denoted by small letter f. This is a convention used. Points are represented by capitals and distances are represented by small. But only for radius of curvature, distance is represented by capital R. Now, this point is called focus. This distance is called focal length. Let me consider this plane. This is scale, right? This plane. This plane is perpendicular to principal axis, passing through the focus. So this plane is called focal plane. So let me draw. Focal plane is the imaginary plane perpendicular to the principal axis and passing through the focus. So this plane is called focal plane, the perpendicular plane like this. Now let us go through reflection through. Now let us go through reflection by a convex mirror. Since it is convex mirror, the concave surface is the reflecting surface. Let this be the principal axis. Consider few incident rays, one along the principal axis just like this previous case, and few more parallel to the principal axis. Now, let me consider some point on the principal axis inside the mirror. These rays will undergo reflection such that they appear to be coming from this point. Students, keep these 2 points as reference and draw the reflected ray. Okay, so this is the reflected ray. This reflected ray appears to be coming from this point. Let me show that by dotted line. So this should be, these two should be confined to a line. Now let me draw reflected ray for this. To draw reflected ray, consider these 2 reference points. Keeping those 2 reference points, let me draw the reflected ray. And this reflected ray appears to be coming from this point. So this is second reflected ray. Now if you consider reflected ray along the principal axis, what happens? Even the reflected ray of this should be from this point. So naturally, if I try to draw, that reflected ray will be along the principal axis only. Again, this reflected ray is something similar to this normal incidence. So this represents reflection at normal incidence. Now reflected ray of this observe, all these reflected rays appears to be coming from some point behind the mirror, and that point is the focus. This is pole. Distance of the focus from the pole is the focal length. So this distance is focal length represented by small letter f, and this is focus. For this reason, concave mirror is also called a converging mirror. And convex mirror is called a diverging mirror. Converging or diverging nature of the mirror can be concluded by looking at the reflected rays. See, after reflection, light rays converge. After reflection, light rays diverge. Students, now concentrate. After reflection, if the light rays converge, then that forms a real image. This is one of the conditions for real image, formation of real image. Here, the reflected rays diverge. They diverge means they never intersect after reflection, and these rays appears to be coming from some point. Appears to be means this should be virtual. So if the reflected rays are divergent, then that forms a virtual image. And just like previous case, if you consider an imaginary plane perpendicular to the principal axis and containing the focus, then this imaginary plane is called focal plane. Now, how to trace reflected rays and how to get image by concave mirror. First concave mirror, after that let us see with respect to convex mirror. Students, try to follow and copy the diagram, and the outcome of the diagram helps in solving multiple choice questions in seconds. Trust me, in seconds. So in few entrance exams you'll get 1 minute per question, but using these clues you can solve in 10 to 20 seconds. Trust me. So show interest and draw these diagrams, copy these diagrams. I'll show you step by step. Okay. First case, when object is within focus. Draw principal axis very lightly. So this represents principal axis. After that, let me draw the spherical surface which represents a concave mirror here. So this is a concave mirror. Let us shade the mirror afterwards. Let me mark a point at a distance 4 centimeter. This is for focus, and at a distance 8 centimeter. 1, 2, 3, 4, 5, 6, 7, 8. So this represents center of curvature and this represents focus, and this is the pole. CP should be twice FP, and we will be solving this relation. We will be proving this relation. So this is 1 unit, means this should be half unit. Let there be a linear object within the focus. Somebody is standing and it is represented by this. So this is the object O. Okay. Now consider a ray from the foot of the object. If it is incident on the pole, you know, after reflection from the mirror it retraces. So this is the reflected ray from the pole. Next, consider a ray from the head of the linear object. If this is a ray, and let this ray be parallel to the principal axis. Understand? If this height is about 1.5 centimeter, at a depth 1.5 centimeter, put a dot. You have to join these 2 points. Now, if you draw a ray parallel to principal axis, then this ray after reflection should pass through the focus. Means like this. Let me consider third ray from the head falling on the pole. This third ray. If this is the incident ray, this is the principal axis which represents normal, then angle between incident ray and the normal is called angle of incidence, I. Since angle of reflection should be equal to angle of incidence, we have to make sure that the reflected ray should be such that I equal to R. Now how to keep I equal to R means there is a small clue. If you take this object as 1.5 centimeter, at a depth 1.5 centimeter, put a dot. And keeping these two as reference, try to draw the reflected ray. This is the reflected ray. See, reflected ray along the principal axis. These two are two more reflected rays. If you observe these two carefully, then these two are diverging rays. Diverging rays means they never converge on this side. And these two rays appears to be coming from some point. Let us find out that point. There is a ray along the principal axis, right? Let me produce this back. So wherever these two meet, there draw the image. So this is the image. I stands for image. See, for this object we get this image. After all this, try to shade carefully. Don't be in a hurry. Draw neatly. Now this represents concave mirror, object, image. If it is a mirror, we expect image on the same side as that of the object. But here, image is on the other side, means behind the mirror. For that reason, this image is virtual. Virtual means imaginary like. The other way of telling virtual, the reflected rays are diverging. These rays appears to be coming from some point. Since these two are diverging, that should give virtual image. So it is virtual image. You can clearly see that this is magnified. This is bigger than object. So magnified. So what is the nature of image means? It is virtual, magnified and erect. If head is up for the object, head is up for the image. It is not inverted. So that is why erect. Erect, magnified and virtual. This is the nature of the image when object is between focus and pole. Focus and pole. Now, how to use this concept? Suppose focal length of a mirror is 30 centimeter and object distance, U stands for object distance. Object distance is 10 centimeter. What is the nature of image means? Just check. Focal length is 30. Object distance is 10. Means object should be well within focus. That time this condition gives virtual, magnified and erect image. Now what is the nature of the image? If object is at F, First, draw the principal axis. Next, the spherical surface. Next, at a distance 4 cm from the pole, one more 4 cm. So this represents center of curvature and this is the focus. This is pole. As usual, let us shade the mirror later. Let object be at F. There is a linear object at F. Let me consider a ray from the foot of the object along the principal axis. After reflection, it retraces the path. This is incident ray. After reflection, it retraces. Second, parallel to the principal axis. If the incident ray is parallel to the principal axis, what should be the condition? After reflection, the ray should pass through the focus. Ray should pass through the focus. Now let me consider ray from the head of the object incident on the pole like this. Now to trace the reflected ray, there is a small clue, right? I told you in the previous case, if height of the object is 1.5 centimeter, make sure that you mark a point below this at a distance 1.5. Now join these two points. Join these two points. See, these two are parallel. These two are parallel means they never converge and they doesn't look like appear to be coming from some point. Now after completing all this, don't forget to shade the mirror. Don't be in a hurry. Shade it neatly. So here, image is at infinity. That much is enough. Image at infinity. I cannot claim that the image is real or virtual. To say real, these two should converge, but they are not. To say virtual, they must be appear to be coming from some point. It is not. That is why if we can write this much, that's enough. Image at infinity. Third case, when the object is between C and F. This is for the principal axis. This is the mirror. At a distance 4 centimeter, 1, 2, 3, 4. Focus, 1, 2, 3, 4. Center of curvature. Center of curvature, focus. Now, let the object be between C and F. This is the linear object. Consider a ray along the principal axis from the foot of the object. After reflection, it retraces the path. Incident ray, this is the reflected ray. Another ray parallel to the principal axis. After reflection, this ray should pass through the focus. Third ray from head of the object, incident on the pole. This is the pole. To trace the reflected ray, what should we do, students? Keep this height as reference and find a point below the principal axis at the same distance. Keeping these two as reference, draw the reflected ray. Naturally, the angle of incidence will be equal to angle of reflection. Just check. This is angle of incidence. This is angle of reflection. These two will be equal if we do this small arrangement. So this is the reflected ray. Wherever these two reflected rays meet, there forms the image. So this is the image. I. This is object O. This is center of curvature. In our diagram, we have kept radius of curvature equal to 8 cm. And this is focus, F. Now let me shade the mirror. Now, looking at the image, identify the nature. The image is obtained by converging rays. See, these two are reflected rays. These two are converging. Therefore, it is real image. You can see image is bigger than the object. So, magnified. And image is inverted. Head is upside down. Therefore, inverted. So, real, magnified and inverted means the object should be between C and F. In this case, in a problem, if object distance is taken as or given as 40 centimeter and radius of curvature is 50 centimeter. See, radius of curvature is 50 centimeter. Half of this is the focal length, F equal to 25 centimeter. This object distance is between 25 and 50 means this is between C and F. So for this position, image will be real, magnified and inverted. That's how you should identify looking at the position of the object. Let us keep object at C, center of curvature. Okay. Spherical surface, concave mirror. At a distance 4 centimeter. 1, 2, 3, 4. Focus 1, 2, 3, 4. Center of curvature. Now let us keep an object at center of curvature. Now consider a ray along the principal axis. After reflection, this should retrace the path. Second ray, parallel to the principal axis. After reflection, it should pass through the focus. third ray from the head falling on the pole, from the head to pole. So after reflection, to trace the reflected ray, make sure that this height equal to this depth and join these 2 points. Join these 2 points. Now observe, this is I and this is R. Angle of incidence equal to angle of reflection. Wherever these two meet, there forms the image. So this is the image. Surprise, right? This point is center of curvature. This is focus, pole. This is the object and this is the image. Don't forget to shade the mirror. Reflected ray. Now students, can you guess the nature of image? Height of the object equal to height of the image. So that says magnification equal to 1. This says height of the object equal to height of the image. Actually it is -1 because inverted. So let me represent it by magnitude. Magnitude of magnification equal to 1. Then image is inverted. And image is formed due to converging rays. That is why it is real. Real inverted and magnification equal to 1 means height of the object equal to height of the image. This is true. Magnification 1 is true only when object is on the center of curvature. Okay. Now fifth case, when object is beyond C. So let me draw principal axis. These 2 points are for my reference. This is for the concave mirror. At a distance 4 cm, 1, 2, 3, 4. Focus, one more, 1, 2, 3, 4, center of curvature. Let object be beyond center of curvature. So this is the object. Ray along the principal axis. After reflection, retraces. Incident ray, reflected ray. Second, ray parallel to the principal axis. After reflection, passes through the focus. Sorry for the background music, okay, if you hear anything. Another ray from the head to the pole. This is pole P. Again, if height is about 1.5 cm, make sure that depth is also about 1.5 cm. Then you have to join these 2 points. That ensures that angle of incidence equal to angle of reflection. This is the reflected ray. Now this is the position of the image. Position of the image will be there where reflected rays meet. Let us shade the mirror. You can see diminished image. This is object O, center of curvature C, focus F. This is the image I, pole P. So it is real, students. Why it is real image? Because image is formed due to converging rays. Inverted, no issues. And then diminished. This is smaller than this. So if object is beyond C, then size of the image decreases. So it is diminished. If focal length of a mirror is 20 centimeter and object distance equal to 60 centimeter. See, object distance is 60, focal length is 20. Focal length 20 means radius of curvature should be equal to 40. And this image is, this object is beyond C. Beyond C means center of curvature. Therefore, this case should give real, inverted and diminished. Students, copy all these diagrams, practice, and based on the position of the object, make sure that you know the nature of the image.